Hi, I'm Priyesh Nayak. I'm a DevOps engineer at GeekyAnts, and today I'll be talking about Kafka and some of its core components. So let's see what is Apache Kafka and why it matters. So Apache Kafka is a distributed event streaming platform that enables real-time data streaming and also event processing. It also provides very high throughput and it is very much fault tolerant. Secondly, it provides a scalable architecture. That means it has a partition log model. Partition log model, in the sense, it allows data to be split and processed in parallel. That means it supports parallel processing and also load balancing. Some of its use cases are real time analytics, log aggregation, event sourcing, and also data integration pipelines. So, unlike the traditional queues, Kafka actually stores all the records in the form of categories called topics. So, these topics actually enable us to replay them and also provide scalable processing. Some of its core components are producers, consumers, and partitions. So, let's see each one of them. So, producers are basically the ones which sends the data to the topics, and consumers read those data from those topics, and partitions are the one which enables parallelism and scalability between them. uh, Two core components are brokers and zookeepers. So brokers are the servers that store and serve Kafka topics and partitions, and zookeepers are the ones who manages the cluster metadata and coordinates leader election as well. Let's see how the Kafka cluster is set up and how it is configured. So first of all, we have the installation and configuration. In that Kafka, we will be installing Kafka in Ubuntu 22.04 and with some configuration files. We'll specify the broker ID in it and also the network listeners, which will be bound to the public IP that will be accessed externally. Then we have systemd services for managing Kafka and zookeeper services. This processes is used for automating startup and monitoring. We will also set up multi-broker setup. So in multi-broker setup, unlike one broker, we'll have multiple brokers, more than two brokers. So which will have its own unique ID, and it will be but it will be connected to the same zookeeper. And due to this, it will have cluster coordination as well, and it will have the same metadata. Brokers that are registered with zookeeper enables cluster awareness, and also it provides fault tolerance. So I have provided certain steps over here how you can install Kafka on your Ubuntu 22.04. So first of all, we have this wget command where you're installing this archive file, and then we will be mentioning the broker ID, as I have mentioned, in the server.properties file in first broker, in the first server. This is how we will mention inside the server.properties file. So for the broker 2, that is later on, we will have a different server, and over there we will mention the broker 2 as well, which will have a different ID again, and it will be linked with the same zookeeper that is running on the first server. How can you say that? Over here, if you see, we have zookeeper.connect equals IP1. So that is how it will be connected with the zookeeper that is running on the first server. So these things I have already done on the server, and I will show you what I have done. This is my server one, and I'll be showing you the server.properties config file. Over here, you can see that we have this broker ID 0, and I have mentioned its IP, and as well as the listeners, and also the zookeeper ID over here. So I have basically configured the broker one in the particular server one. Next, we'll see on the server 2 how I have configured the broker 2 as well. So here, as you can see, we have mentioned the broker ID. the second broker, that is, it will have a unique ID obviously, and it is linked with the first server. So I have set up broker ID in both the servers now. Next, I will be adding these systemd files. That is for the zookeeper and Kafka. As I had mentioned, we need this zookeeper and Kafka as well for running the services. And obviously, we need Java as well in this. So this is my zookeeper service file where I have provided the description and how it will restart. So all the configurations of the zookeeper, I have mentioned it over here. Same way, I have mentioned for the Kafka as well. So this is my Kafka configuration. It will be a similar file with some changes according to the Kafka. So this will start the zookeeper as well as Kafka on the server 1. So let's check the status. My Kafka is running. For this, I have used these commands, that is daemon reexec, daemon reload, and zookeeper Kafka that I am enabling, and as well as starting. So all these 4 commands I have already run, and that's how my Kafka and zookeeper is running. So as you can see, both the Kafka and zookeeper are running. Now the CLI commands which I have used to create a topic which will store the data basically. So I have used this command where I will create a Kafka topic named test topic for our first demo. So I have already created this topic. To show you, you have to list the topics over here, and for listing the topics as well, I have provided the command here. I'll just show the command. So as you can see, we have a test topic over here. Okay, now you might be wondering that I'm doing everything on the server 1 itself. So what's the use of server 2? So as I said before, the server 2 as well, it will be linked with the server 1 cluster. As I have linked the zookeeper service with the server 1, where the zookeeper is running on the server 1, right? So I will show you here as well the same command. Let's copy this one. And let's run it over here. So as you can see, we have test topic over here as well. So this is how we can say that both the servers are linked with each other, and we will get the same data, same topics simultaneously. So now that we have verified that we have created the topic, let's move on ahead. So we will create a simple producer and consumer code where we will produce certain messages, and we will receive those messages on a different server, let's say on the server 2, where I have registered with the same zookeeper, right? So we will test out how Kafka works. So first of all, in producer, as I said, it will send the messages to the Kafka topics, where it will store them using Kafka.js client, and these are connected to the brokers and publishing data asynchronously. Consumers, on the other hand, what it will do is it will subscribe to these topics where the data is stored, and it will process these messages from the beginning, and it will show you all the data that has been sent. So for doing the end-to-end test, what we will do is we will first of all run the consumer on the different server so that it will be available to receive the messages. And on the other server, what we'll do is we'll run the producer JS code so that it will produce all the messages, and we'll receive it simultaneously on the different server. Let's do that. I'll show you the code what I have used. First of all, for the producer JS, I've used this code where I'm mentioning the files I'm mentioning the library, and as well as I'm mentioning the broker where it is mentioned. So I have mentioned the broker over here, first server IP, and then I have written a simple uh, function over here which sends the data. Similarly, for the consumer JS as well, I have mentioned the same IP of the first server, and I have also mentioned the topic that this consumer will fetch from. So here we are using the test topic, right? So we'll fetch all the data from the test topic from the beginning. So that's why I have provided here from beginning true, and small function which will just read out, which will collect all the messages which we have got. So let's see the code and how it works. So this is my server 1. If I do ls, you can see I have the producer.js code over here. I'll just show you. So this is the producer.js code. Same code exactly what I had mentioned over there. And on the other server, I have kept the consumer.js code. So I'll show you this as well. So we have this consumer.js code which will receive the messages from test topic. So now let's run the consumer.js code. Okay, as you can see, my consumer.js code is ready to receive all the messages, and it is using a test group, right? Over here now we will run the producer.js code. Okay, we have this message that got sent, message sent, hello from Node.js Kafka producer. So this is my server 2, and you can see that we have received the message simultaneously. Received message, hello from Node.js Kafka producer. So this is how parallel processing works, and this is how they are linked with each other. Let's close this. So now we have tested how these topics work and how messages are sent from one server to other. Next, we will move on to load balancing and partitioning. What's partitioning is the topics that are present that are divided into partitions. Partitions in the sense like shards of data that enables parallel processing, as I told before, and due to this it will also provide scalability, and leaders and replicas as well. So leaders are like each partition has a leader broker that is handling the read writes with the replica for fault tolerance. And of course, we have load balancing, messages that are distributed across platforms, partitions, and consumers in a group are assigned partitions exclusively for parallel consumption. We'll see what are the codes and commands which we have used. First of all, we have created a different topic, that is balance topic. Now we can see that we have created a topic named balance topic, and we have used the partition as 3. So we'll have 3 shards of topic, and we have given replication factor as 2 with the first server IP. So I have already run this, as you have maybe noticed before that I have the topic already. I'll list and show you. So I have already created this balance topic, and here as well. Let's show it once again. So here as well, we have this balance topic over here. Now we have used these codes for producer load balancing and consumer load balancing. This also has a similar code where instead of sending a single message, what it will do is it will send 10 messages. That's why I have added the for loop over here. I'm using the broker that is present in the first server, and I have written a small for loop over here that sends all the messages, 10 messages to the topic. And for the consumer load balancer, I have written a similar code where again I have provided the first server's IP, and I have written a small function where it will use the balance topic. It will fetch from the balance topic, and it will get all the 10 messages that that the producer has produced or sent it. So let's see this working. First of all, this is my server one, and we have the producer load balancer code over here. I will just show you. So this is my producer load balancer code. It's the exact same what I have showed you in the PPT. Similarly, we will show the producer code. So as you can see, we have here consumer load balancer. Same way, this also has a similar code where the server one's IP is mentioned and the group IP as well is mentioned. We have mentioned the topic over here, balance topic, which will fetch the data will be fetched from the balance topic, and it will receive all the data. So let's run the consumer code first. Let's say node consumer load balancer. So now my consumer is ready to receive all the messages. We will run the producer code. Node producer load balancer. So here you can see it has sent 10 messages 0 to 9, and we should receive 10 messages in our consumer as well, right? So this is my server 2, and as you can see, we have received all the messages simultaneously. So this is how load balancing works. This is how like all the messages are sent parallelly. What we can do extra is that instead of writing only one IP over here, the server 1 IP, we can also mention the server 2 IP as well, where we have a different broker. Right now it is only using a single broker that is present on the server 1. So if you mention the server 2 IP as well over here, it will use the broker 2 as well, which is present on the server 2, and it will distribute these messages like equally. So let's cancel this one. So as I told, Kafka ensures partition level ordering, and the order might vary sometimes. So each consumer in the group will be assigned one or more partitions. Right now we had 3 partitions, and messages are automatically distributed across all the partitions, and each partition is handled by one consumer instance, which provides parallelism and also the load distribution, as I told. So in Kafka, only the round robin is officially supported as of now, as you saw. Let's see how Kafka works when we have a failover, and how a new leader is elected when there is a failure in Kafka. So first of all, we'll simulate the process of the broker failure. We will stop a broker, and automatically the Kafka should elect a new leader. Secondly, we'll have the replication and in-sync replicas. So what this will do is, whenever the broker fails, it will restore upon the recovery. It will provide the replicas of these data whichever is sent. Then we'll do the manual leader election, and we'll see how the leader is elected manually. For that, first of all, we'll use the same topic which we had created, that is balance topic. And again, instead of partition 2, we'll use partitions 3. And then we will create a topic called balance topic. And then we will simulate the broker failure. We will stop the broker 1, and then verify like how Kafka promotes the leader election. Then after that, we'll bring back the broker as well, and we'll select. We will manually elect the leader. Okay, so now we'll test the working of this. Let's go to the server 2, and what I'll do is I will stop the broker, this broker 1 that is running. So we will run this command. So we'll run this command and we will stop Kafka over here. Let's check the status of Kafka. So as you can see, Kafka is not working basically on this server as I have stopped it. Okay, now what I can do is I can check how many topics are there, and I can check the ISR as well. So for this, what I can do, I will just run this command where it consists of the server 1 IP, and I am checking the balance topic. So in this, as you can see, we have ISR only 0. Initially, we would be having 0 and 1 as well. But as we have stopped it, we'll have 0 itself. So now what I can do is I'll bring back the Kafka. Okay, this thing will, just to verify, we'll run it on the server 1 as well. Okay, it shows the same output. So what we'll do is we'll bring back a Kafka. For that, we'll run this command, systemctl start Kafka, and now let's check the status of Kafka. Okay, Kafka is running. Now we'll run the same command to check the ISR, whether it has regained from 0 to 0 and 1 as well. So this was the command. Okay, now as you can see, we have regained the replication factor 2, and we have ISR as 0 and 1, both the brokers as well. We have it. So this is how the leader election happens. If one of the broker goes down, another broker will be assigned to it. Here, as we had 2 brokers, one of the brokers were used. Okay, so now as we have regained all the ISRs, now we'll move on to the next step. The next step for us was adding new nodes and rebalancing it. So adding new nodes in the sense we'll add new brokers to it, and we'll register a new broker, and we'll reassign the partitions manually. So for new broker addition, I have a code over here. I'll just share it. So if I go to this directory, basically in this directory actually I have created Kafka 2. I have written the same Kafka configuration that I had used for the Kafka 1. Same thing I had written in Kafka 2 as well, with a slight change with the broker ID. And I'll just show you the configuration. In this file, this is a separate file compared to the first Kafka which was present. In this file also it consists of the same codes, just that we have given a different ID for a broker. So how many ever brokers you create, you need to create a different file for it. You can't register it on the same file. So here we have server.properties as I had showed you. So we will start the Kafka. So we'll restart the Kafka 2, and we'll verify its status as well. So as you can see, both Kafka service 1 and 2 are running on the same server, that is server 2. Now let's verify the brokers. So now as you can see, over here, initially we had just 0 and 1. We had just 0 and 1. Then now after adding the third broker, we have 0, 1, 2 as well. All the three brokers are shown here. Now let's do the partition reassignment. For this, what we will do is I will create a reassignment.json file, and in this JSON file, we will keep this code where I have mentioned in parts. So first of all, we'll have a balance topic which is already there, and we will use all the three brokers alternatively. So for the partition 0, we will use 1 and 2, and for partition 1, we'll use 2 and 0, and similarly for partition 2, we will use 0 and 1. So this file I'll just show you. So this is the file that I just showed you in the PPT. I'll have the balance topic and the partitions and its replicas. So after this, what we'll do is we'll execute that particular file which we created, and then we'll confirm whether it ran successfully or no, whether it got reassigned, the partitions got reassigned or not. So let's just go to the server 1. We will run this file. Okay, so we got a message called successfully started partition reassignment. Now let's check whether it has reassigned all the partitions or not. Okay, so as you can see over here, we have the topics, and we have three partitions over here, and leaders are basically the brokers. In the first partition, as I had given, we have uh, two replicas, that is 1 and 2. Either of them will get assigned as a leader. So in this, one got assigned as a leader. Similarly, for the partition 1, we have leader 2, and we had replicas 2 and 0. Similarly, for the third one, we have leader 0. So you can see that the partitions actually got reassigned. Now let's move on to the next. So we will increase the replication factor now, and we'll check whether it works, whether it provides high redundancy. So it's increased to 3, as I told, because it provides high redundancy, and it's with reassignment plans generated and executed to update all the partition replicas. So for that, we will have this particular file, that is topics to move. In this, we'll mention the topic, and then we will have this reassignment plan, where we will mention the file as well, which topics that we'll be using, and then we'll have a broker list that we will be using to assign. So let's run this file and see. I already have created this file. So here I have mentioned balance topic, and then we'll generate the reassignment plan. This will not this will not send any successful message or something. It will just reassign meant suggestion. That's all. It will just give you a suggestion of the reassignment, including the third broker. So let's run this command. So as you can see, it just gave a suggestion that it's proposing partition reassignment configuration, and it's telling what to do. So next we will create the reassignment plan that it is providing. So for that, I will create a reassignment 3 rf.json, that is 3 replication factor.json. In this, I will I will keep all the 3 brokers as replicas for all the 3 partitions. Previously, I've seen that I have created a similar file reassignment.json where I kept replicas only 2. That means I am using all the 3 brokers, but then I'm using alternatively. I have not included it all together. So in this, we will use it all together. And then we will apply it with this particular command where we are reassigning the JSON file, that is reassignment 3rf.json. And next we will verify whether it has got reassigned or not with all the replicas, and we are supposed to get this particular output. So let's verify whether we are getting that. I will show you the file. So this is my server one, and I have the reassignment 3rf.json file over here. So as I said, I have used all the 3 replicas alternatively over here in this particular file, and next we will run the file that we have created. So we got the message that is successfully started partition reassignments for balance topic, because we have used the balance topic, and it has used 0, 1 and 2 brokers. Let's verify this with the command. Okay, now we have changes in this. We can see that previously we had only 1 and 2 in the replicas, and even in the ISR we had 1 and 2. But now we have all the 3 brokers together for all the 3 partitions. So this is how all of them are reassigned to each partitions. So we have successfully got this kind of similar message. So this tells that it has reassigned successfully. So the key takeaways and what you can do next is that we have seen about Kafka's strength, which is scalable, it's fault tolerant, and it provides event streaming. It provides parallel processing as well. Its main components are partitioning, replication, and later election. Then we have seen its practical implementation using the Node.js code for normal sending message one time with a load balancer as well. And then we have seen its cluster resilience. That means we have seen how a failure of a broker will lead to manual leader election or automatic leader election. So this provides high availability. Then it supports load balancing as well. What we can do is we can explore more advanced Kafka features like custom partitions, its security, how it is managed, how it can be monitored, and I hope you like this video and you gained knowledge on Kafka. Thank you.